Hey, MathCounts, what's going on? I've got a little lesson today called Work Word Problems. This is from the 2022-2023 season book. So let's get into it. So word problems, most of them, can be solved just as a fraction, comparing the number of jobs done to the time taken to do it. Pretty obvious, and then kind of just using proportions. But there's some problems that you're going to need to come up with kind of a different method. And these are usually when they're working together or working against each other. So here's our first example. We've got two more participants trying to complete a job together. Person A can do the job in 10 minutes. Person B can do it in 15. How long if they work together? Okay, so this is really, this is a type of problem I see a lot on MathCounts. I think they even did a poster on it one year, something like this. But basically what I like to do, there's multiple ways to do these problems, but what I like to do is I like to use fractions, and I like to state in 1 unit of time how much of the job can people do. So the first guy, he can do the job in 10 minutes. So in 1 minute, he can do 1/10 of the job. The other person can do the job in 15 minutes. So in 1 minute, he can do 1/15 of the job. So you got 1/15 there. Now together, in 1 minute, they can do 1x of the job. I don't know how long it's going to take them, but it's 1x of the job to do it. Okay, so to solve this one, I would multiply by the, was it GCF? I can't remember the, anyways, what number does 10, 15, and x all go into? 30x. So 30x, I can multiply both sides of the equation by. 10 goes into 30x and I'm left with 3x. 15 goes into 30x and I'm left with 2x. X goes into x and I'm left with 30. 3x plus 2x is 5x. And then I just divide by 5 on both sides. And it looks like together it would take them 6 minutes to do the job. Because in 1 minute they can do 1/6 of the job. So it would take them 6 minutes to do the complete job. The other way to do it that you might see is if you've got a person doing the job and you don't know what the second person's going to do, but you do know what it takes to work together. So person A can do the job in 15 minutes. Together, when they do it together, they can do it in 10 minutes. So in 1 minute, they can do 1/10 of the job. How long can person B do it by themselves? So you see on this one, we just don't know what the second person is, but we know what they are together. And it's the same solving. We multiply by 30x. We end up with 2x plus 30 is equal to 3x. We'd subtract 2x from both sides, and we get x is equal to 30. So it looks like the second person could do the whole job by themselves in 30 minutes, because in 1 minute, they can do 1/30 of the job. Person A stacks 10 bottles in 10 minutes, while person B is unstacking the bottles. How long until they are stacked? Okay, so this is a different one where they're actually working against each other. We've got person A stacking, it takes them 10 minutes, while person B is unstacking the bottles. How long until they're stacked? Never mentions that person B is doing a 15. I think I'm just assuming it was the same. It's the same problem as this one, except now they're working against each other. All right. Anyways, so again, person A can do 1/10 of the job in 1 minute, whereas person B can do 1/15 of the job. They're working against each other. One's stacking, one's unstacking. I want to know when they're all stacked. So same solving method. We just multiply by 30x, because that's the number that 10, 15, and x would all go into evenly. And here I would get 3x minus 2x is equal to 30. So x would be equal to 30. So it would take them 30 minutes to, while they're working together, for them to finally get stacked. Anyways, fraction rules. So if you've got a fraction under a fraction, there is a really quick way to do these. I mean, you could do 1 divided by 3 over 2, and then do 1 times 2 over 3 and get 2/3. The other thing to look at is if you've got a fraction in the denominator, you can take the denominator of the denominator and just move it to the numerator. This is helpful several times if you got fractions inside of fractions. So the 2 would move up to there. 1 times 2 is 2 over 3. And you can even take it farther. I don't know, let me see. Let's just say that you've got 1/2 divided by, I don't know, I'm just making stuff up at this point. Let's go 4/5. So we can do this really quickly if we got a fraction divided by a fraction. Instead of turning it into a problem like this, the 2 would go with this 4. The 5 would go with this 1. So that's something we can do really quick when we're dividing a fraction by a fraction. So on the numerator, I'd have 1 times 5. And the denominator I'd have 2 times 4, 8. We can see that this is actually true because we can do the whole, what do you call it, like keep, change, flip? Is that what they called it in 7th grade? So 1 times 5 is 5, 2 times 4 is 8. We can see that it works. So, I mean, you could do this step, but this is just a quick way to work with fractions. If you're dividing fractions or fractions within fractions, it's going to help, especially for this particular set of problems. All right, I think that's all I got. This is a quick one. See you guys later. Bye-bye.